Thanks for tuning in. Chris Rice Crypto with World Alternative Media here. And when I joined World Alternative Media, I said that I would cover content giving use case with blockchain and cryptocurrency technology. And today I want to talk about a project that I'm very excited about called Nexus that I think are doing innovative and groundbreaking things in the space, utilizing 3D blockchain, quantum resistant technology, and satellite ground technology as well. So today I get to be joined by the founder, Colin Cantrell, who took time out of his day from coding to do this interview. Colin, I appreciate you doing the interview. How are you doing today?
Doing pretty good, brother. Thanks for having me.
Thank you. So one of the things I wanted to ask was, I've found that Nexus is a great project, but it's very complicated and a lot of technical things going on with the project. So I wanted to ask if you could simplify a little bit about what Nexus is to somebody who's unfamiliar or new to the cryptocurrency space.
Okay, so essentially, Nexus is kind of a movement. It's a collection of a lot of different facets of information. I guess the fundamental is the technology that's driving it, which is essentially a tool set that allows us to kind of make these changes. But it's kind of an idea that's existed around for a long time. It's about connecting with people, connecting things together, and improving these situations. So we're, working on the tool set with the satellite technology for kind of physical and telecommunication. And then obviously the distributed ledger for cryptocurrency and advanced contracts so that we can start to automate and have more safer levels of the world. And then, creating a more distributed, decentralized internet that allows us to have kind of a censorship free and take things into our own hands. Because the technological revolution over the last 40, 50 years has really brought this world into a completely new level. And a lot of access to the technology still isn't in everybody's hands, similar with cryptocurrency or with satellites. It's because the cost is so high in order to learn. There's a learning curve associated with it. There's a lot of things that you have to understand, and it's a very complex technology. So we're really working on condensing it and making it something that people can use and something that's practical in everyday life. Not just, hey, we're going to make countries with this or whatever. It's like, well, hey, how can we influence this world? Well, we got music. We have a lot of different businesses. We have supply chains. We have escrow. We have all these different amazing things that can be done. Tokenized assets, tokenized data. And I think that's going to really, really, really change the scape of a lot of the world, because it essentially allows us to check and balance one another. And it kind of puts power back to the people. It democratizes that power. And it creates kind of a more sociocracy rather than, autocracy like we have now.
Right. I like that. And that's one of the things that I really like about the Nexus project. There's a lot of really great organic things that you're incorporating. The idea of Tau and with the Tritium white paper. So could you also, one of the things that I had done was an interview in the past with Anastasia, who works with Nexus, and we were talking about the Tritium white paper. And one of the complications that I had is I'm not really a technical person. So I had a hard time understanding what the white paper was about. And I even read a Medium article that was trying to simplify it, and it was still a little bit over top of my head. So do you mind giving a little bit of a simpler explanation about the Tritium white paper?
Yeah, I'll do my best. I guess you can say reality is built in layers. It's kind of a concept that's been borrowed. So if you take, if you look at it, we have space, then we have matter, then from matter you have atoms, and then atoms create compounds, and compounds create elements, and then elements come together to form tissue, and so on and so forth. So these layers of the world is kind of how it works. And it comes from very simple components being at the base. So the idea with the Tritium software stack is to add layers of abstraction. Abstraction basically means most computers are extremely abstracted now, which means I can fire the computer up, I can type in some stuff, and I can see pictures and all these fun things instead of seeing all these byte code, right? Now, I'm a lower level guy. I deal with the byte. So you get down lower, just like if you get, into lower levels of matter, you start understanding quarks and gluons and how all these things function, and it starts getting really fun. But essentially what we're doing is we're working on creating these layers of abstraction where you give a specific role to each layer. So the base layer of the Tritium stack is the network. So what network is it's essentially how packets are transmitted between computers. Think about it as the language computers talk to with one another. That's all a protocol is. So computers need to talk over the network. So that we're using multicasting and everything. Multicast basically means I can talk to a room of a bunch of people. I'll get the message at the same time. Now, unicast is essentially you have to whisper a message between one another. So essentially, that's the network layer. Sorry, it looks like our internet slowed down a little bit.
Yeah, I think we're good though.
Okay, so then we get to the next layer, which is the ledger layer. So the ledger is a layer of abstraction on top of the network, which essentially creates a cryptographic trust layer. So the trust of it comes because all of us verify it, kind of like the scientific method. Your truth is not a truth unless people can independently verify it. So the ledger essentially is storing data, and it's locking the data into an immutable fashion so it can't ever be changed. And that's where you get a really beautiful aspect to the trust of it, because you know that once I record something in this ledger, it's there forever. And that's how you can do financial transactions. So then on top of that, we get what's called register layer. So a register, just think of it as a memory location on the network. So I can store this data on this register, like my account can be this register. And that's how computers function on the lower levels. They use register inside the CPU. So if you want to add A and B, you store them both in a register, and then you store the total in C. That's where your front side cache comes from, the processor anyway. So it's kind of borrowing off of how the natural processing works. Like Ethereum and Bitcoin and all of them, they're stack machines, which means you got to push and pop things on a stack instead of storing it in an easy to accessible way. And then we get to the operations layer, which gives context to the registers. So the operation layer essentially is doing certain things. And the upper operational layer can also act as a messaging system to support triggers and things like that. And then it can touch the ledger, or it can pull data from the ledger. And then you get to the API. Now, this is the really beautiful part, is the API is going to make it easy for anybody to be able to access this network. Right now, there's about one blockchain developer for every 16 job openings. So there's a huge deficiency in blockchain developers. Why? Because blockchain is extremely low level right now, and it's extremely complex, because complexity is simplicity multiplied. So Ethereum is just this big glom of code that's just so complex to do. And one thing could lead to 100 things. That's how computers work. I mean, it takes a specific type of person. I mean, if we had web developers coding down on layer 3 of the IP layer, I mean, we wouldn't have a very successful internet. And it's because people that actually know what they're doing go down on these lower layers. So you find less and less developers that are capable of those things at these lower levels. So what this API is designed to do is essentially allow everyone to plug in from their logical and their interface layer, which is going to be the new application space. And you can basically say, hey, I want to store this data. Hey, I want to store this copyright. Hey, I want to check this copyright. I want to check this data. I want to create these tokens. I want to transfer these tokens. All these different operations that basically give context so that you're interacting and going down the stack, and then it passes to the network. It comes back up the stack on the other side. And that's similar to how the internet works. The internet has the OSI stack, which has the physical link, which is your copper and fiber. Then you have your Ethernet layer, which is your MAC addressing. And then you have your layer 3, which is your IP. If you know, you hear about IP addresses, that all happens on layer 3. Layer 4, TCP. If you hear TCP IP, that's layer 4. Layer 5, you have your session, which is your sockets. Layer 6, presentation, and layer 7, application. So the OSI stack, as we have it on the internet, is designed that way because it scales. If everything on layer 1, if the physical hardware had to process every single packet or process everything Google is doing, it wouldn't be efficient, right? It's the packets are just moving. The routers are just moving packets. And that's kind of how the ledger, you can see this. It's just going to be moving packets, which are going to be transactions. And it's going to be cryptographically verifying them to make sure that they came from the right person, that they're stored in the ledger, so on and so forth. So you could consider the OSI and the Tritium stack as one and the same, where the Tritium stack is actually just adding layers of abstraction onto this. And in a way, it's finishing the internet and solving a lot of these deficiencies we have in it, like key management, man-in-the-middle attacks, IP spoofing, and a lot of other things. So that's, I guess, a basic nutshell of the Tritium stack. And that's how we're going to get advanced contracts to be able to scale. Because when you have everything done just in one glom, it doesn't really have much modularity and ability to change. So with this, we're going to have different developers on each level, so that most regular application developers now will be able to develop contracts on Nexus without needing to have the sophisticated blockchain programming knowledge.
Okay, that's very impressive. And that's one of the things I like about Nexus. I mean, I look at Nexus as being a game changer, and I definitely want to let people know what this project's about. And one of the things that I just found out right before we did the interview is that Nexus is doing a partnership with BitSpace. Can you elaborate on that?
Yeah, so BitSpace is working in a similar fashion on trying to get satellite support. They're also over in Norway, which is cool. So it's kind of opening up some of the Nordic region, decentralizing things a little bit more. So essentially, we're working on creating kind of an alliance, because in order to have a distributed internet, we can't put up all the satellites. That's not going to be distributed. That's just going to be another ISP. So what you got to do, you got to build a model that can be replicated. And that model being replicated, anybody will be able to take those open source designs and then put them up there. But the other big part about it is the standardization process. The internet as we know it has standards, and that's how devices can cross communicate. As you're starting to notice, USB-C is becoming a standard for all of your devices here, or you have your airport, or you have the regular USB, which, you know, it's universal serial bus. And you need to have these specific standards. Otherwise, people are going to make this, and then they're going to have dongles and modules to make them all work. And that's inefficient. So One thing we're working on with the satellites is creating kind of this alliance where you can have crosslinks. So your bit modulation pattern on layer 1 will be the same frequency and the modulation pattern, so the satellites can talk to one another. So BitSpace or us or whoever else can put up these satellites, but they can all talk to each other. And then you start to create a mesh network in space that allows all these satellites or anyone to join it and then service the traffic for it. Because right now, the way the internet works is you have cables strung across the ocean floor. And one of those cables costs $300 million, and they're owned mainly by AT&T. And that's a bit of a problem because, I mean, cables get shut down. I mean, I think there was riots over in Spain or France, you know, a few weeks ago, and then they shut down the internet, you know, and it's just, the internet, I think, is something that's really, really imperative for our future and for our evolution, because it allows information to travel freely between one another. It allows things to be questioned, things to be challenged, things to be understood, and for people to be able to connect. And that fundamentally is part of it. So BitSpace is kind of joining with us on this alliance in order to start to deploy more and more of these satellites, so that, you know, you, Chris, could just deploy a satellite and we could join the whole cloud, and then you become a part of the mesh, and then it becomes owned by a lot of different people, and anybody can choose what they want to do with it.
That's awesome. And can you tell me some things that is going to be going on with the future, some plans you have going on with Nexus?
So right now it's deploying, I mean, I guess on the code side, we're doing the Tritium framework right now, which is getting deployed. I'm going to see some fun demos for it at the conference. We're doing some standardization working groups similar to the IETF model, which is how the internet gains its standards. It's called the Internet Engineering Task Force, and they meet 3 times a year, and they go through, and that's how TCP/IP got standardized. That's how all of the RFCs got standardized. That's how actual elliptic curve cryptography got standardized. Everything that Bitcoin and cryptocurrency uses is using what these guys built. Okay. And so we're kind of creating that model again, but for blockchain, because these blockchains need to be able to cross-communicate. You need to have standards between them. And the operation layer and the registers need to be standardized as well in working groups with a lot of different developers that see a lot of different angles. I think it's a specific study where if you have a big jar of jelly beans and you ask people to guess how many jelly beans are in there, after a certain number of people, the actual average of all their guesses becomes within 0.5%. So in that same type of concept, you know, we all see a lot of different angles. So bringing the right people together into these working groups is really important to standardize the protocol. And then we got Amin and Obsidian after that. So Amin is mainly focused on the 3-dimensional chain. That's where we're going to have the kind of grid state channels. Tritium is going to be just kind of a single dimensional state channel with some basic L1 locking. And then Amin's going to start gridding it that way. And then Obsidian is going to be wrapping it up with the miners and the distributed mining pool. And then also the community governance model, which is really important because a lot of these cryptocurrencies that are supposed to be decentralized have CEOs, or they have central foundations that control everything. And that's something that needs to be distributed because, I mean, power corrupts, and absolute power corrupts absolutely. So, I mean, just when you have something that's capable of changing the world in such a beautiful way, you don't want to have it limited by just one person. It really is the self-organization of everybody working together that makes that possible. And so that's something that we're aiming at, is kind of borrowing models from sociocracy and working on our own type of spherical-based social organizational models that are also a stack as well as social stack. And that's going to be important because social scalability is a big problem we have in cryptocurrency, as we've seen with the block size debate, with EOS, with politics, everything. So those are some interesting things on the horizon. We have a satellite launch, I believe, in March. We have a conference coming up in September. I think the 19th through the 22nd, where we actually have our first working groups.
Since you mentioned it, I wanted to talk about the conference, which it's the September 19th through 21st in Scottsdale, Arizona. And you can buy tickets at thenexusconference.com, but we'll have links down below for all this. So can you tell us a little bit more about the conference, what's going to be going on there?
So the conference is kind of bringing a lot of different like minds together. So essentially what we're doing is it's kind of going to be a small group of good people, and that's kind of how we're doing. We're trying to do it different. Most crypto conferences nowadays are sham and glam and look at me and look at this and come buy this coin and whatever. We're about like, let's get some stuff done, guys. So we're going to have the blockchain 101 on the first day, and the second day we're going to have a lot of keynotes from people ranging from many satellites, blockchain. And then we've got another important part on the last day is the working groups, where essentially we're going to have the standardization process. So there's a social working group, we're going to have a ledger working group, we're going to have a network working group, we're going to have an actual API working group, and then a contracts working group, among others, which essentially allows people to join each layer of abstraction based on the level of understanding or desire to understand that. most people would generally be interacting, hey, I want my API to do this. So I want these API calls. I want this to do this and that to do that. And then that trickles down to us guys down on the operation register ledger layer, where we say, okay, well, we need all these registers to do this, and we need all these operations to do that to make these API calls happen. So it's kind of like you spec it from the top and then build it as it goes down. And then the network working group is going to be led by Dino Farinacci. He's one of the original fellows from Cisco. And he's kind of one of the fathers of the internet. And it's been really, really wonderful working with him, because he's taught me a lot and kind of diving me down the OSI stuff, where I've only really gone down to TCP. And now he's showing me TCP dumps, and we're working with Lisp and everything. So it's going to be really exciting, because we're setting the first standard that we can do every year, so that you can say, hey, how do I contribute to Nexus? How do I get involved? I'm a business. I want to make sure it does this, or this does that. How do I get in? Well, you go to a Nexus conference and you can have direct input into development, because there's a bit of a separation between development and use cases in blockchain right now. There's just the developer saying, hey, we're gods. We built this. You figure it out. And we kind of want to help bring those together, so that businesses, people, community, all of that, we can contribute and really make this something. Because, I mean, that's what's made Nexus what it is now, is people working together on it. I mean, I'd be lying if I said everything was my idea. It's just a lot of people's ideas that have come together to create this beautiful idea that has become.
Teamwork makes the dream work.
Exactly, brother.
So, Colin, thank you again for taking the time to do this interview.
Of course.
What I would like to do in the future is a more detailed follow-up on my YouTube channel. And I just want to encourage all the World Alternative Media listeners to check out Nexus. I'll have links down below. Check out the conference coming up the 19th through 21st of September in Scottsdale, Arizona. Also, check out my personal YouTube page. That's at Rice Crypto. It's 2 words. Subscribe and check out my past content. And as always, I encourage you to be the change by practicing change.
Like what you see, Hero Am? Don't forget to check the links below. GoFundMe, Patreon. We can't do it without you. Any donation is very much appreciated, especially as we are so overwhelmingly demonetized by YouTube as they bring in the ADL to flag all of our content as hate speech. Also, check our Bitcoin address in the description, as well as on the screen for you to scan if you please. And also check us out at STEEMIT at Josh Sigurdson, the future of social media, where you get paid in the upvote of your post in cryptocurrency, Steem that is. So don't forget to check us out there, and find us at Anarchapulco 2019. I know it's early, but this is such an exciting event coming up with Ron Paul, Judge Napolitano, David Icke, Larkin Rose, Jeff Berwick, all the usual characters, and it's going to be amazing. So we hope to see you there. Make sure to check the link for Anarchapulco below and use promo code WHAM to save as much as 15% on your tickets. We hope to see you there. But until next time, this is Josh Sigurdson signing out from World Alternative Media. Find the truth, be the change.
I'm sure you have already changed people's minds in your young age because you're involved, and I like that.
Thank you.